I'm just going to talk and show you things as they come. And I'm really embarrassed, actually. So here's the basic idea. So I'm sitting around one day. I was about 46, I think. And I'm sitting in a cafe drinking coffee, which, if anyone has any coffee, by the way, that would really help me right now. Is there any coffee in the tri-state area? No?
Tri-state area maybe, but it's not.
Not around here?
Oh, Davey he's got an espresso maker.
No, it's just a Mr. Coffee.
I'll have a Mrs. Coffee, a Miss Coffee, any kind of coffee. But it would be nice to have some. So it would really help. Thank you. I just flew in today. I woke up at 6:15 this morning in Chicago, and I just got tired. So thank you. So I was sitting around wondering how many 7-note scales there were that you just used whole steps and half steps. I was really curious. I said, I've been improvising for a long time. I was at a point in my life where I wanted to know some definite answers. It's like, how many are there? Are there like 1,000? Are there 50? Are there 87? I was just I reached this point where I just wanted to know answers. So I started thinking about it. And I realized, okay, we have a 12-tone octave. So to have 7-note scales that use whole steps and half steps, there can only be scales with 5 whole steps and 2 half steps, or else it doesn't add up to 12. If you have 4 whole steps and 3 half steps, it adds up to 11. If you have 6 whole steps and 1 half step, it adds up to 13. So there can only be scales with 5 whole steps and 2 half steps. If you're dealing with just whole steps and half steps, I'm not talking about harmonic minor and things like that. Okay, 7-note scales. So for example, a major scale, whole step, half step, whole step, whole step, whole step, half step. So some old math came back to me, and I was one of the worst math students you'd ever want to be around. After about the 3rd day of math class, I would usually glaze over and look at other people's assignments and write down, what they were doing on their tests just so I wouldn't fail. I was like allergic to math, but I did remember a few things. So I made up an equation. And so I said, let's call a whole step X and a half step Y. So 5X plus 2Y equals 12. Okay? Pretty simple, right? So if you played that scale on a piano, 5 whole steps and 2 half steps, it sounds like this. So the first note isn't an interval, it's just a note. So the first interval is the second note, is what you hear. So. I don't know if I've ever heard anyone play that scale before, but that's 5X plus 2Y. And so I just thought I'd call it, does it have a name? Do you know the name of it? Anybody? I call it the whole tone half step scale, because it's a whole tone scale and then it has 2 half steps. Of course it has 7 modes, right? The wheels are turning up in Ed's mind. He's going to write a tune tomorrow. And then this one. And so, oh, that's interesting. So how many other ways can you arrange 5x plus 2y? So my very bad math student brain said, how about 4x plus y plus x plus y? So that's 4 whole steps, a half step, a whole step, and a half step. So that is linear augmented, which is the whole melodic minor scale system. The major 7 sharp 5 is basically the relative major of the melodic minor. And this is kind of, I like to call this scale, it's the connective tissue of jazz. It's, without it, jazz as we know it wouldn't exist. So that's 4x plus y plus x plus y. And so another way you can arrange 5x plus 2y is 3x plus y plus 2x plus y. So I'm doing the most number of x's first, okay? And so this sounds like this. That's a Lydian mode of the major scale. Well, I have news for you. Those are the only 3 ways you can arrange 5x plus 2y. 5x plus 2y, 4x plus y plus x plus y, 3x plus y plus 2x plus y. So the answer to my question of how many 7-note scales that used whole steps and half steps, there's 3. That's it. And then each one has 7 modes. And of all the times that I've talked about this, I only met one person who I said, how many scales do you think there are? And this one guy went, 3. And he's a really great musician, and I think he's kind of a savant, really. Do you know C.J. Vanston? Did you ever know C.J.? We played tons of sessions together in Chicago. He was like the jingle keyboard player with like a tech brain, and he does all the music for the Christopher Guest movies. He's been in Hollywood for years and produced Toto's last album and stuff like that. So CJ and I were hanging out, and he just said 3, and I went, yeah. Like, how did you know that? He said, I don't know. So it's pretty interesting, and I have this written out in graphics. I hope this is the correct one. Yeah, here they all are. The whole tone half-step scale. So, and I have the x's and y's for each one. See, 5x plus 2y, 4x plus 2y plus x, 3x plus 2y plus 2x. And in a certain way, it's almost like musical genetics. You know, these are almost like strings of genes arranged into musical chromosomes in a way that you can think of them this way, if you want. And the Lydian augmented scale, and the Lydian scale, I'm just starting with the most amount of x's. You could call them whatever you want to call them. So this was sort of a mind-blowing thing for me to realize this. And then the really interesting thing happened. I'm sitting there drinking this really good coffee, and I start to think about human hearing. And if you look at any spec sheet for a microphone or speakers, the usual thing, if you see a mic that has a full range, it says that it goes from 20 to 20K, 20 cycles per second to 20,000 cycles. That it'll pick up sound in that range, because that's pretty much thought of as the limits of human hearing. So if you listen to a piano, for example, you have A440, every octave is double if you go up. You know, that's 880, that's 1760, sort of. And that's, boy, I can't multiply right now, 3520. So it's like this is like 4K, and we can hear it at 20K. And if you keep going down, 220, 110, 55, I mean, not really, because piano tuning is done in stretch temperament, and the high notes are actually sharper, and the low notes are actually flatter, because human hearing isn't linear. my best friend. Thank you so much.
Black or
Cream, but it's okay. Thanks. Thanks. No, it's, I'm going to get smarter in a second. So I started thinking about, you know, being a piano player, there's certain chords that sound better, certain voicings that sound better in certain registers. You know, our ears can hear chords a lot better here than they don't sound like chords up there because hearing's not linear, you know. And down here, it sounds like a bunch of mud. I mean, we can't play chords down there because the vibrations are too slow. When you combine all those slow vibrations together, the way that our tympanic membranes function, we can't differentiate between them. It sounds like mush. Now, maybe a whale would be able to hear differently, okay? Yeah? And maybe these high sounds, maybe a hummingbird could hear. You know, but if you start thinking about it, the word hear has the word ear in it. And I'm sure that's not a coincidence. It's like of the ear, something like that. I didn't look it up. But if you go down low, you can hear the individual vibrations, like that. You can hear that string shaking. I'm really glad we have a 9-footer too. You can really hear it. Because this is where cycles per second cross over into the realm of beats per minute. Because that low one there is about 25 cycles per second, which is approximately 1,300 beats per minute, something like that, like a drum roll. So I started thinking, okay, this 5x plus 2y stuff works really well for figuring out scales. I wonder if it has any application to the world of rhythm. Because when you get into beats per minute, that's the realm of rhythm. Because rhythm, it's a vibration, but it's too slow to be heard by the ear. If someone's playing, we hear it as rhythmic accents. We don't hear it as continuous vibrations, because here we're hearing, this is 440 times a second that our tympanic membranes are picking up this vibration. It's vibrating at the same speed as this note. Okay, I mean, just think about it. The human body is in the middle of all these vibrational fields. So rhythm is something that we feel with our bodies and we can count with our minds. So I thought, why don't I try this 5x plus 2y stuff with rhythm? Like, let's just see what happens. Like, just this wild leap of faith here. So let's see if there's anything to this. So if you're going to assign a rhythmic value to 5x plus 2y equals 12, I thought, how about a bar with 12 beats in it instead of an octave with 12 notes? So let's say a bar of 12/8. So 5x plus 2y equals 12/8. So what would x be?
Like a quarter note.
Huh?
Like a quarter note.
Quarter note. And y is
It's
an eighth note.
Yeah.
So 5 quarter notes plus 2 eighth notes equals 12/8. And I said, just so I don't waste too much time here, I wonder what the rhythmic equivalent of the major scale is. So, whole, whole, half, whole, 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 half, now becomes quarter, quarter, eighth, quarter, 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 eighth. Anyone want to tap that out? Yeah.
Right?
Yeah, it's... And I almost fell off my chair, because that's the main bell pattern in Afro-Cuban music when you're playing in triple time meters, like 12/8, 6/8, 3/4, whatever you want to call it. And I'm just sitting there, it just blew my mind. And I'm thinking, well, there's something about these numbers that the main tonal scale that is used in European-based music is the same, based on the same numerical formula as the main bell pattern in Afro-Cuban music. So cultures that have rhythm as their most prominent feature, and one culture that has rhythm as its most prominent feature, and another one that has melody as its most prominent feature, are both using the same equation to generate their principal material that's music. And then I thought about this and I went, well, you can have rhythmic modes of these rhythmic patterns. So, for example, I'm going to get to I'll just do the major scale one on the bottom here. So if you just visualized the major scale, whole, whole, half, whole, whole, half, whole, 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 half, quarter, quarter, eighth, quarter, 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 eighth. The rhythmic Dorian mode is going to be quarter, eighth, quarter, 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 eighth, quarter. So it's actually palindromic. So, whoops. That's this one. It's the one second from the end here. You see, it's the same thing forward and backward too. And so then the Phrygian mode of the Greek modes. Anybody here not know what the Greek modes are? Everyone knows. Good. So the Phrygian mode, it starts with a half step. So that one is the last one here. That's ba-ba-ba-ba-ba. So this really blew my mind that you could have a whole system of rhythmic patterns based on the same exact equation that gives you these 7-note scales. And so this gives, in terms of, if I were running a music education program, I would ask students to write pieces of music in all 7 modes of each of those scales, and just the melodic material. You can harmonize them any way you want. And then I would also have people figure out bell pattern, tumbao, and clave for all of these different rhythms. So it's kind of a friend of mine said, a unified field theory of music that makes you understand that when people talk about, usually they say there's 3 elements in music. There's melody, rhythm, and harmony. I'd like to say that they're just vibrations at different speeds, and that we describe them by the limitations of our physical being, that we have to separate these vibrations by perceiving them separately with different sensory organs. Or else we would just sit around under a tree all day and go, oh man, you know. So it's good that we separate these things. Because if you don't, that's why people do drugs, is like you feel it all together, synesthesia, right? It's like, oh man, did you smell that tune? You know, that kind of thing. Because they're all, you know, our synapses and our nervous system is all connected together in a way that's supposed to allow us to actually function in the world, you know, physically and mentally. So that it's good to understand that these things are unified, but then like it's a matter of how you use them. So the other thing that I thought about was, and I'll show you the rest of these things. So this is what the 5x plus 2y rhythms sound like. You can see why that one wasn't too popular. It's kind of boring. There's too many quarter notes in a row. You know? But it gets more interesting a little bit. Not much more. But the last one, that's pretty cool. So it's interesting to see these rhythms that are generated from a mathematical formula. And then I've actually heard some of these beat patterns in certain Afro-Cuban music, the melodic minor system, or whatever you want to call it, linear augmented system. first one, and then second one. So there's all these different rhythms. And of course, you can do this with other mathematical values as well. I don't want to really get into that right now because I don't have enough brain power this morning to talk about dividing the octave into 10 notes instead of 12. I mean, I've messed around with all of these things. But the other thing I'd like to mention to you is that Western music notation is inherently biased toward pitch and against rhythm. Because if you think about it, the pitch is absolute. There's a note on a line or in a space, it's G, it's an A, there's no mistaking it. But rhythmic notation is symbolic because it was created after pitch notation. They had to figure out how to notate rhythms and say, okay, this one lasts for 4 beats, this one lasts for 2 beats. They don't look like 2 beats or 4 beats, they're symbols. So if you're gonna have actual rhythmic notation, maybe it would look a little bit more like this. So that's 3x plus 2y up there. And the next one, it's much easier to read. You don't have to convert a symbolic language to sound. And it also creates a nice design. You could do this with architecture if you wanted to. It's pretty interesting, isn't it? Almost like an LED, like a screen that would light up for the different ones. So each of those is a different rhythmic mode of the first one is Lydian, right? And it can also work tonally. So and you could also play the modes in the same rhythm that they're in. So if you have the C Lydian, it would be. So that gets really interesting, is to play a mode in the rhythm, in its corresponding rhythm. And the other thing is thinking about modes and rhythms as having colors or shadings from light to dark. For example, if you just use the 7 Greek modes, if you start with the Locrian, I'd say that's pretty much the darkest mode because it starts, it doesn't even have a fifth. Everything flat second, flat third, flat fifth, and then it opens up a little at the top. If you start thinking coloristically about these modes, or at least light and dark. That's a little less dark. And opening up, the more whole steps you have in a row, the lighter it is. It's almost like the raised eyebrows of a Lydian mode. And you can also make line drawings of these things. Someone told me that Paul Klee wrote a book about this, and about relating drawing to musical sounds. Someone just yesterday told me this. So, the other thing that relates the two worlds of rhythmic accents and pitch sounds are, if you think about the natural overtone series. Does anyone here not know what the natural overtone series is? Everyone knows?
Yeah.
Harmonics? Okay. The easiest way to show it on a piano is you just hold down a low note and then you play the notes that are there when you hit that low C. That string's vibrating at its full length, half its length, a third of its length, a fourth of its length, a fifth, a sixth, a seventh. This is like mathematical inevitability. That's the way the universe works. It's vibrating at every fractional part of its length. So half of its length is an octave, if I hold down the C and not play it. A third of its length is the next fifth up. and a fourth of its length is the next octave, and then a fifth is like this third, and a sixth is this one, this one, this one. And then they get weird and out of tune with our tuning system. But I started thinking about the ratios of the intervals that are created from the natural overtone series. So the perfect fifth, anyone know what the ratio is of the perfect fifth? It's 3:2. So if you, for example, if you play A220, and I'm not talking about the tempered scale, just the Pythagorean scale, like non-tempered, the E, a fifth above it, would be 330. That's a ratio of 3:2. And the reason why is that it's the difference between, you know, your first harmonic is half the length of the string. The second harmonic is a third the length of the string. So it's the difference between half and a third, which is a ratio of 3:2. That's one way of looking at this. So if you slow down this interval of a fifth 100 times, you get the polyrhythm, 3/2. So all of the intervals, which are based on pure mathematical ratios, their analog in the rhythmic world is polyrhythms. So the perfect fourth is a ratio of 4:3, and that's the polyrhythm. If you slow it down from 330 and 440 cycles, if you slow it down 100 times, it's 4/3. So you start seeing that that polyrhythms are actually intervals, rhythmic intervals. And the next one, the major third, if you're going, is a rhythm of 5/4. Now, what's really interesting about this is that these rhythms, these patterns start showing up in folk music and in dance music in different parts of the world. But they're tempered a little bit. They're not the pure mathematical ratios, like Frevo in Brazil and Bossa Nova, you know. Just like we temper the scale so that we can play in every key. If we didn't temper the scale, a whole bunch of keys would sound like crap. So people do the same thing with rhythms. They've changed, but I don't know if this is conscious or subconscious, but you can look at certain rhythms from certain cultures and say, that's really close to 5/4, that's really close to 4/3, that's close to 6/5. They are very close to being mathematically perfect, but they're not, because they're changed around a little bit to make them sound better. But then there are some things that are mathematically perfect. And if you listen to, there's certain African drumming traditions where our musical minds are not trained to perceive all of the different rhythms that are going on in some African tribes drumming. But believe me, there's a whole bunch of rhythms happening. And it creates rhythmic harmony. Just like we have a chord, you know, that's our harmony. Well, if you have like 3 or 4 separate drum beats going that are creating the same exact mathematical ratios as a 7th chord, you know, that's the rhythmic harmony. And I'll show you an example, okay? Just the major triad. You got 3/2. You got the major third, which is 5/4. And you got the minor third, which is 6/5. So in that triad, you have 3 different rhythms going on. 3/2, 6/5, and 5/4. So if you got assigned 3 drummers, or 4 drummers, I don't know how many it would take. I don't know if I should like figure this out and actually write this down and have everyone do it. But if you could play them on different pitch drums, you can come up with the rhythmic equivalent of the major chord. So this is what I mean. If I ran a music education program, this would be what I would do. Because rhythm is something that's an inherent part of our beings, but in Western civilizations, it's not taught, it's not given equal stature most of the time. And hence there's all these terrible jokes like the definition of a drummer, someone who likes to hang out with musicians, that kind of stuff. Well, in India, a friend of mine who's a tabla player told me, you know, the definition of a tabla player in India is someone who carries the sitar player's sitar, you know, because they're paid less, even though these guys are unbelievable. He was expressing the frustration of being a rhythmic accompanist and in North Indian musical tradition, that the tabla players are always held in slightly lower esteem than the melodic players. And I just find this fascinating that it's all vibrations. So if you get slower than rhythm, this is where it also gets interesting. So I describe anything slower than the speed of walking. If you can't walk to it, then you can't feel it, and it ceases to become a rhythm. And then I say it has periodicity. Like I don't know where I found that word, but that's a word I found somewhere in my mind. And I discovered that other people use it too, after I wrote this stuff all down 20 years ago. So I find it very interesting that the number 12 and the number 7 and 5 and 2 keep reoccurring. So if something is slower than like 60 beats per minute, it's awfully hard to feel it. You have to subdivide it to feel it. You have to like do 8th notes or 16th notes or something. So if it gets really slow, to count it, you start needing a watch. Minutes, okay? And minutes are divided in seconds. It's very interesting that watches have 12 hours on the dial. I find that fascinating, that we have our 12-note scale. It doesn't seem arbitrary somehow. And the watch has 12 numbers on it. And then there's 12 hours, and then you repeat those 12 hours. And then if you get slower than time with the watch, you need a calendar. Like, calendar is 12 months. And then we have these things called weeks. They have 7 days. And if you're a musician, the calendars that you can buy in the store to write down your gigs in, a lot of them are very frustrating because most calendars that you see are based on people who work for a living. So there's 5 weekdays, right? And then there's these weekend days that they shove into the end that are half the size. And for musicians, it's exactly the opposite. We work on Saturdays and Sundays. I mean, we play our gigs on the weekends, right? So we got 5x plus 2y for the week in the calendar. I find that highly amusing. So, but it is funny. How come we have these 5 weekdays and these 2 weekend days? Why? Who decided this? I don't know. Like, why? You know? I started thinking about all this stuff. And it's like, there's no answer. What's the answer? I don't know. I have no idea. And so, anyway, if you get too slow for the calendar, the 12-month thing, and then you need something to measure really long periods of time, like Stonehenge or something. So ancient people who were watching the movements of stars and planets and stuff, because they didn't have lights at night, and they were watching the sky, and they got their idea of time from observing these bright, shiny objects in the sky and figuring out how long it took them to get from here to there every 22 years or whatever. And it's amazing how ignorant we are now of things that people used to understand a lot about. So that's why, you know, if you step back from music and look at it from these different perspectives, you can see, you start seeing stuff and hearing stuff and being aware of stuff that you weren't aware of before, being so involved in taking everything for granted. So the other question is, so what happens when vibrations get higher than 4K or 20K? So we can't, quote, hear them anymore. But I'd like to think that those are light. So we have our eyes to perceive the faster vibrations, light waves. And I wish I were more of a scientist, but they're vibrating really, really fast, and there's probably someone here who knows. Anybody here good at physics? But they're vibrating really fast, and we obviously can't hear them, but we see them. And so I find it very interesting that if you put a prism in front of a light, it splits it up into 7 colors. Why? I mean, not 8, 7. Damn, that's really interesting. So there have been all sorts of mystics who are trying to ascribe mystical values to all of this stuff for years, for hundreds of years. And I'm really not interested in mysticism. I'm interested in what's useful for playing music and to understanding what actually is. And I find it very fascinating that all of these things are interconnected that we normally perceive as separate. And so I think that for music education especially, that all of these things should be explained to people. Okay, here's another interesting idea. The pentatonic scale. If you think about it, well, if you think of the piano, I find this pretty interesting. The black keys of the pentatonic scale, the white keys of the diatonic scale. So you have Europe and China. It's interesting, it's just the way it works out. But if you look at the pentatonic scale, what it is, it's the first 5/5 of the circle of fifths folded into itself. If you do it in C, it's that. If you go up to the next fifth, you have a dissonance between the B and the C. But the first 5/5, there's no dissonance. Everything is consonant. And it has 5 modes because there's 5 notes. And so I thought about this for a while. I thought, why is the scale so popular? Well, it's because there's no dissonance in it. And so that's why Irving Berlin had a special piano. He only played an F sharp. And he had a piano that had 76 keys, and he could move the action down to transpose. Did you know about this, Ed? Yeah. So if you think about Irving Berlin's melodies, like Blue Skies, you know, I mean, play it in F sharp, you know, and that whole opening melody is just it's very Chinese, you know, if you take the chords away from it. So he understood the inherent consonance of the pentatonic scale, and that's why he liked playing in F sharp. Also, a lot of pop tunes from the 30s that had very complex harmonies. If you look at the notes of the scale of the melody, a lot of them just had the notes of the major scale, or just even 6 notes of the major scale, and surrounded by interesting harmonies. So it's an interesting exercise to try to compose melodies just based off like really, really simple scales and see how interestingly you can harmonize them. So let me see what else I have here. See if I made it through most of my stuff. Yeah. I've actually written down, oh, that one, yeah. This is pretty interesting. I could play you a tune, if I can find it here on my iTunes. That's a really interesting example of a different application of the same idea. This is an album I recorded in Japan rather. I'm not sure if it's gonna Okay, it's a traditional Macedonian tune. I played this with a guitarist named Miroslav Tadic. Any of you guys know who he is? He teaches at Cal Arts in California. He's a really interesting musician. And a drummer named Mark Nassif, who I used to play with a Lebanese oud player named Rabbi Abdul Khalil, who I toured with for years in Europe. So I'll ask you guys to tell me what rhythm this is in. Oh, except that we're not hooked up sound-wise, are we? No. Oh, for Pete's sake. You know, I have a little USB speaker with me. Oops. Pretty sure. Yeah, these will be able to hear. Hope it's charged. I'll just plug it in because I'm not sure if it works with the laptop. So what this is, it's this one. Very abstract version of. It's in 12. It's 1, 2, 3, 1, 2, 1, 2, 1, 2, 3, 1, 2. What's interesting is that that's the rhythmic Dorian mode. I actually left out a step of this whole thing, but it's 1, 2, 3, 1, 2, 1, 2, 1, 2, 3, 1, 2. Do you see where I'm moving the cursor? And what's interesting about this tune is that the melody is also in the Dorian mode. So I find it interesting that the rhythm and the melody of the tune. So it's a unity of the rhythmic pattern and the melody, so like to step back further from it, this is a much slower thing than the Afro-Cuban 12/8s that are really fast. This is a really slow 12/8. Okay, now what I forgot to tell you is relating the pentatonic scale to a rhythmic pattern. That's what I was building up to, but I sidetracked myself, I'm sorry. So the pentatonic scale has total harmony. It has no dissonance. So in these Afro-Cuban rhythms, like the one that, the main bell pattern in 12/8 here, one goes. That's also called the cascara, and the unifying force in Afro-Cuban music is called the clave. And so the clave in 12/8 is, it's 1, 2, 1, 2, 3, 1, 2, 1, 2, 1, 2, 3, basically. So what we do is we take out the eighth notes. When you see the major scale, which is this one. Bam, bam, ba, bam, 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 ba, bam. The clave takes out the eighth note and just has quarter, dotted quarter, 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 dotted quarter, if we're writing it in 12/8 like this. And so I realized that what that is the rhythmic equivalent of the pentatonic scale. That the clave is a rhythmic pattern that has no dissonances in it, that all sorts of other rhythms can coexist around. And it's the one that this rumba clave in Cuba, that also later became more squared off to be in 4/4, but it started out being in this 12/8, in this triple time meter pattern, is the rhythmic equivalent of the pentatonic scale. So it would be spacing to a quarter, dotted quarter, so it would be whole step, minor third, quarter, quarter, which is whole step, minor third, dotted quarter. So it would be from C sharp on the black keys. So it's another example of something fulfilling the same function in tonal music and in rhythmic patterns, in a rhythmically based music, to have this thing at the heart of it that everything radiates outward from. The same way that Irving Berlin's melodies are so simple, but that he has all these complex harmonies that all go around this very simple chord. So this is the same thing that when I was doing a tour with drummer Steve Smith. Do you know about him? He's a very amazing drummer who is also, he plays everything great, but he's gotten extensively into Indian rhythms in the last 10 or 15 years and does a bunch of tours with Zakir Hussain, playing Indian stuff on drum set amazingly. And he would do these solos where he would play 3 against 2 with his feet, you know, and then play everything over it. I said, Steve, that's the same thing as Indian musicians playing over a drone, a fifth. Because in almost all Indian music, the drone you hear is a fifth, you know. Whatever raga they're in, whether it, so the ratio of vibrations in a perfect fifth are 3 against 2, 3 to 2. And so he's doing this with his feet, and he's playing in all these other rhythms. I said, yeah, you're doing the same thing, but you're just doing it in a rhythmic 3 against 2, as opposed to this drone that everyone hears. So if you start thinking this way, you start being able to see the unifying principles behind musical elements that are normally thought of as 2 separate worlds, and it's really all one big world. It's all just vibrations at different speeds. I'm sure I left out something, but that's it in a nutshell. Any questions? I'm happy to answer questions. I'd like to answer questions. I'd like to hear questions. Yeah?
Can we get copies of this?
Well, it says copyright Howard Levy, so I guess you can, yeah. Yeah. I should really publish this thing.
You should.
It's like, I've done lectures on it, and yeah.
So, if you say that everything is connected, and I really agree with you on that, it sounds like it makes sense that everything will be connected. But you can connect it more in the theoretical way, in like the way you know. And what do you get to say about like what you did about like exploring the way that it feels? You know what I mean? Like the interaction with the sound or with the feeling of the, you know, the vibration, like you talked about it through the body, and
Yeah.
not only through like the theoretical way.
Yeah, I mean, every one of these things feels differently, and it's hard to know sometimes like which things are individual feelings and which things are cultural feelings. Like the same sounds in different cultures can mean different things, you know, because they say music's a universal language, but not really. I mean, because different things mean different things. Different sounds mean different things in different music. For example, one of the funniest experiences I had, I used to play in a Greek wedding band in Chicago, and I played mostly saxophone in this band, but sometimes I'd play harmonica. They let me play harmonica sometimes. And sometimes I'd be wailing away and playing the bluesiest stuff I could think of. I'd get no response at all. It's like, well, I'm not used to this. Like, usually if you play like one blues note for a bunch of Americans, they go, ah! You know, these Greeks, they're dancing away, they're not saying anything. I go, what did I do wrong? And the bouzouki player said to me, just play the fourth. The fourth? Really? He said, just trust me, you'll see what happens. So I said, okay, I played that as my first note. So I'll just show you what happened, you know. So for example, it was just this groove like it's a slow dance called the Samiko. So I was going, I was playing, you know, all this bluesy stuff. Nothing, no reaction. I played the fourth one. It's like, oh wow. Okay. I wouldn't have thought of that. But that's like their cultural emphasis. That note really grabbed them. And so, yeah, different things mean different things to different people. It depends on how you were brought up and what these notes, they're saying something to you, you know. It's like language, you know. And then we get into the whole thing of the tempered scale, the non-tempered scale, microtonal intervals. And this gets really interesting because I tried to play some Arabic music, and right away you run into the fact that they have 17 notes in the octave, and how are you going to do it on a harmonica? I mean, I can sort of do some of it on the harmonica. It feels really great, and I listen to a lot of this stuff, and at first, sometimes you could start feeling seasick listening to this music because they don't have chord changes, but their microtonal variations are their flat 13s and their sharp 11s, you know. They've decided to make everything it's like their geometric designs in the Arab world. You know, everything is incredibly elaborate and mathematically worked out. And the microtonal music is incredibly worked out, and it's really, really precise. One guy explained it to me that it was different amounts of the Pythagorean comma, which is 22 cents. That's the amount off that the circle of fifths are. If you play every fifth in a ratio of 3 to 2, you get from C to C, you're going to be 22 cents sharp. And that's how the tempering the octave is the distribution of those 22 cents over the 12 tones of the scale. And so they've worked out their music theory. It's truly amazing. I played in a conservatory in Amman, Jordan one time, and this little kid came out and played some Western classical stuff on violin, and he was really great, and then he played some Arab stuff, and it was like, sounded like a different instrument, because the microtonal stuff was just there, and he was equally as comfortable playing those intervals as he was playing all the Western stuff perfectly in tune. And this is yet another musical frontier that very few Westerners have really ever crossed, is understanding how to play traditional microtonal music of the Middle East, and doing it correctly and doing it precisely. Of course, blues has tons of that stuff in it. And, you know, like Albert King and B.B. King and Freddie King, everybody bends notes a little bit differently, you know, and it grabs you, and it's not It's in between, it's in the cracks, you know, and that's why it gets to you. But in Middle Eastern cultures, they've worked this stuff out really, really precisely. And it's a science, and they teach it. You know. And of course, rhythmically, in these parts of the world, and in places like Eastern Europe and India, North and South, we're rhythmic infants compared to these people. They very casually play in so many different rhythms. They're expected to, because they don't spend their lives studying harmony. So the harmony in that music is the interaction between the melody and the rhythm. That's the harmony. And a lot of times they are playing rhythmic melodies, as I've explained to you. Yeah. Any other questions? Yeah.
So I say like music is overall, what we try to sell it is like a feeling.
Well, I had all these good instincts, but I'm looking at these charts like, what's the 13th chord? When I was at Northwestern, I played piano in the jazz band there because I sounded better than anyone else, but I wasn't a music major or anything. And so they stuck these charts in front of me. It's like, I'd never seen a real jazz chart. So I'm going B flat 13. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Oh, it's the 6th, but it's up there. So what's in between? Oh, it's that. It's like, so that's how I learned, is just by looking at these things and trying to figure out what the hell it was, because everyone assumed that I knew how to play, because I sounded good and I had like ideas and stuff, but I didn't know what I was doing. But I did know what I was doing on a certain level. And so maybe that's why I figure all this stuff out, is because I've never studied this stuff. I've always gotten the gig and learned how to play on the job, you know. I played Montunos wrong in Latin music for years too. I'd like to, you know, convert to Catholicism and, you know, and say a lot of Hail Marys to apologize to all those guys I played with. Yes? Yes?
Yeah, but you checked out players when you were young?
Hmm?
Because you were in a jazz band, so and you could play jazz, but you checked out the music, the players?
Oh yeah, I was totally inspired. What it is the way I got into jazz. You know, everyone gets into improvising in different ways. So I improvised from the age of 8, right? I would just sit down at the piano and make up stuff. In whatever style of music I heard that I liked. But I didn't know anything about jazz. My parents didn't listen to jazz. They listened to classical music and a lot of Broadway stuff, which I discovered later was all the standards that the jazz musicians were playing. So I kind of developed an ear for some of that. And then I started playing rock and roll and then blues. But then I heard my first Coltrane album when I was 17, and that's how I got into jazz. It absolutely blew my mind. It was my first religious experience. I heard the Crescent album, and I got obsessed with it. I said, I didn't understand what they were doing. I loved it. I just listened to it thousands and thousands of times, and it was the year after Coltrane died, so I had no chance to go hear him. But I looked in the newspaper, and I said, well, let's see, McCoy Tyner and Elvin Jones and Jimmy Garrison. It said that Elvin Jones was playing somewhere. It's like, okay, I'm gonna go hear him. My first live jazz experience was hearing Elvin Jones and Rahsaan Roland Kirk play together. And that ruined me for life. Except before that, I actually remember sitting in, you know, I'm Jewish and they have these bar mitzvah parties for Jewish boys who were 13 years old. I would sit in with the bar mitzvah bands. I would go up to these guys and say, you know, I knew this song, I heard it on the radio, can I play with you? And they'd look at me, and of course they're all jazz musicians, right? This is the 60s. And then some little pipsqueak friend of mine would say, he's really good, you know? Yeah, right, you know. And so some of them let me play piano with them, and I kind of knew what I was doing, and they'd go, oh, kid, all right, you know. But I can't imagine what those guys must have been thinking. Being in that situation myself, of course, years later, I played my share of weddings and bar mitzvahs too. And, oh my God. But yeah, you know, it's how you learn and how you train yourself, and then, you know, you look at these fake books that have chord changes and melodies, and you look at them and you go, okay, and no one's explaining anything to you, and like you look at each chord and you try to figure out what scale goes with it, and you know, of course that's totally wrong and everything, but there's a certain amount of good that can happen from trying to figure everything out by yourself. I don't recommend it. I would never recommend anybody learn the way I learned, but it also created the seeds of me figuring this stuff out years later, this kind of stuff. Of coming from a place of like being like a child, looking at it and saying, it's vibrations. Here's a simple mathematical formula. You know, not taking stuff for granted. Like just because they say you only hear from here to here, what's below that and what's above that? And you start asking questions about the basic nature of things. And it can help your playing. One of the other things, I know I still have a little bit of time.
Yeah, it's about time to wrap, but what,
Yeah. One of the other interesting things that I recommend to everybody, since you guys are students here, I always recommend that people transpose things into all 12 keys. There's no shortcut, so far as I know, to doing that. You either do it or you don't do it. And it will pay you back huge musical dividends. If you just take the simplest stuff and transpose it into 12 keys, take a simple tune and do it, take complex tunes and do it. If you're a classical musician, take the first 32 bars of a Schubert sonata and do it, or a Beethoven sonata, transpose it into all 12 keys. You have to analyze the chord structure, figure out how it works. Take Bach inventions, transpose them into 12 keys. I used to do that with this one. I'm playing in E flat minor. It's in D minor, it doesn't matter. You know. It doesn't matter what key it's in, if you understand how it works. But also to transpose things rhythmically. So do you take that same Bach convention and play it in 7/8? Let's see. I haven't done this. Let's see. Down, down, down. Doesn't matter what key it's in. So, but as a jazz pianist, you have to be able to do that because you're playing with some singer and she goes, okay, let's take the A train in B. It's like, oh, why can't you sing it in C? My voice doesn't sound good if I sing it in C. Like, singers have their keys. And if you're going to play with a singer, they're always the leader, right? And so you're going to have to play whatever tune they ask you to play in whatever key it's in, whether they have a chart for it or not. So this is like musical exercise to be able to transpose, but also transposing rhythmically. I have a funny story about that. I started a band to play Bulgarian music in 1979 called the Balkan Rhythm Band. And one of our guitarists, Pat Fleming, remember Pat? He was playing Night in Tunisia on a jazz gig. And they said, yeah, Pat, let's do Night in Tunisia. Why don't you start it? And he had been playing all this Bulgarian and Macedonian music, and he started playing it like this. He started playing it at 7/8 without realizing it. You know? It works great in 7/8. And I could play it in, I don't know if I could play it at 5/8. I could play it at 5/4. And so you get different phrasing ideas. I've never played it in 5/4 before. So after you've transposed something rhythmically into a whole bunch of different rhythms, playing it in 4/4, you'll have a whole bunch of new ideas. So that's something I wholeheartedly recommend that you guys do. Surround a tune. Play it in every key, in every rhythm, every different feel, Latin, jazz, funk, you know, a shuffle, a waltz, whatever it might be. You want me to hear me play Giant Steps in 11?
Yes.
Let's see if I can, God, I said I could do it. This is a Bulgarian dance rhythm. It's, 11 is one of the standard dance rhythms in Bulgaria, 11/8. It's just groups of 2s and 3s. The 5 is 2 and 3, the 7 is 2, 2 and 3, or 3, 2 and 2. Most 9s are 2, 2, 2, 3. The 11 is 2, 2, 3, 2, 2. So it's like 1, 2, 1, 2, 1, 2, 3, 1, 2, 1, 2. Except it's much faster. It's, the 2s are short and the 3s are long. So it's quick, long, oh, quick, quick, slow. Quick, quick, slow, quick, 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 slow, quick, 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 slow, quick. Tuck, 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 tuck. So anyway, the whole thing with music is just all these different rhythmic and harmonic and melodic ingredients, and you can, if you have a view of them as all being interchangeable parts, you can start experimenting and be a sound scientist. And thank you, Ed, for having me.
Thank you, Howard.